Hey everyone, today I'm going to teach you how to classify chemical reactions. So the last lesson we learned how to balance equations. Now we're going to learn how to classify those equations. So there are 5 different types of reactions that we're going to discuss today. And I'm going to use some analogies relating to relationships as we go through this lesson. So bear with these examples. The first type of reaction is called a synthesis. A synthesis reaction. You might also see it referred to as combination. So that's when you have 2 or more reactants and you end up with one product. And that product is going to be a compound. So it won't be a single element. The reactants can be compounds or elements. So I'm just going to say 2 or more substances. So the general equation for this would be A plus X yields AX. So whatever your reactants are, they join together to form that one product. So the illustration I have for this is just if you get married, the 2 become 1. So you start out as 2 people, now you are a married couple. As we go through this, I'm going to be referring back to this balancing equation worksheet that you used the other day when we were talking about how to balance equations. And we're going to go through this and I'm going to point out to you all the different types that we're talking about. So synthesis reaction, the very first one on this page is a synthesis reaction. So you have 2 reactants, those come together to make one product, water. So that is synthesis. Number 2 is also a synthesis reaction. So you have nitrogen and hydrogen, 2 reactants, they come together to make one product. There aren't any more on the front side of this sheet. If you turn to the back, the very first one is synthesis. Number 4 is a synthesis reaction. And that's it. So that's your first type of reaction, is synthesis. All right, the second type of reaction is the opposite of synthesis, and that is called a decomposition reaction. Decomposition, like I said, it's the opposite of synthesis, so you're actually going to start with one compound, and you're going to end up with 2 or more substances. So again, making this equation the opposite of this would be AX yields A plus X. So my illustration for that would be if synthesis, the example is marriage, 2 becoming 1, then decomposition represents divorce, the couple splitting up back into just individual single people. All right, so looking back at our balancing equation sheet, the first one that jumps out at me is number 2 on the bottom. This is decomposition because you start with one compound and it splits up into 2 products. All right, looking on the back, number 3 is a decomposition reaction. You have 1 reactant, 2 products. And then number 7 is a decomposition reaction. You have 1 reactant, 2 products. Number 8 is decomposition, and so is number 9. So a lot of these were decomposition reactions. All right, the third type of reaction is called single replacement. Now for single replacement, you're going to start with either a single metal or a single nonmetal. And then your other reactant is going to be a compound. And then on the product side, what happens is that single metal or non-metal takes the place of something within that compound. And now you have a replaced single metal or non-metal plus a new compound. So for this example, I'm going to give you two equations. The first one is A plus BX yields AX plus B. By the way, if you hear pounding in the background, my husband is working on our deck today, so I apologize. But moving on, the other equation is going to be Y plus BX yields BY plus X. Now what I want you to notice, the difference between these two is in this first one, A and B are representing metals. So metals replace other metals. And down here, Y and X represent non-metals. So non-metals replace other non-metals. And just keep in mind that for metals always serve as cations. So I'm going to put cations in parentheses because for this type of single replacement reaction, cations are replacing other cations. You'll notice that B and A are always in front of X because cations always come first. And then for nonmetals replacing nonmetals, that's anions. So anions are negative. They always come second in the compound. So that's why you see X and Y always coming after B. So my example for this relationship-wise would be if you've got a couple and then all of a sudden one member of the couple cheats and ends up with a new partner, and now the other member of that original couple is single. So hopefully that has never happened to you. If we look back at our balancing equations sheet, a lot of times when I teach this, I ask, what's the first single replacement reaction that you see? And I'll have students say, well, is number 3 single replacement? And I can see why you might think that. Oxygen is single on the left, but on the right side, nothing is single. Nothing is by itself. So that's what we're looking for when we're identifying single replacement reactions. We're looking for a single element on both sides of the arrow. So the first one I see is number 1 down here at the bottom. This is single replacement because magnesium is single on the left. You'll notice that magnesium and hydrogen switch places. So now hydrogen is replaced, hydrogen is single, and magnesium is now with chlorine. So that's an example of a single replacement reaction. I also have students sometimes think that number 3 is single replacement. It is not.